Hey guys, so today on this video we're going to talk about infinite limits. So before everything was like what's happening at a specific value, now we're going to talk about what's happening at positive infinity or what's happening at negative infinity. So infinite limits. So looking at this first graph, this is the equation or the limit as x approaches infinity of 1 over x. So the equation that we're talking about is a rational function, 1 over x. And so as we approach positive infinity, we want to think about, okay, what is the y doing? Okay, and so as x gets bigger and bigger and bigger and bigger and bigger, what is the y value doing? So the y value is decreasing, 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 but it's not decreasing forever. It's stopping at that horizontal asymptote, which when we talked about rational functions, it had a horizontal asymptote at y equals 0. And so if it's approaching, getting closer and closer and closer to y equals 0, the limit as x approaches infinity of this would be 0. Because the y value is getting closer and closer and closer and closer to 0. Okay, so that's the first infinite limit. Okay, then we could say, all right, I want to know what the limit is as x approaches negative infinity. Okay, and this is sine. So we have sine of x. Okay, as x approaches negative infinity, think about what the graph is doing. Okay, the graph doesn't ever converge on anything. It doesn't get closer and closer and closer to anything. It's going up and down, 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 the whole time. So it's never approaching anything. It's never getting closer and closer and closer to anything when we go to negative infinity. And so, because it's not approaching anything, according to Lindsay Lohan, the limit does not exist. d does not exist. Okay, so that's two examples. One is approaching actual value. One is going up and down, and not approaching anything. Okay, so we have a couple of different scenarios that are going to help us with like what we're doing. So, if your function simplifies to being an odd function, so some odd functions are like y equals x, because it's x to the first power, or y equals x cubed, because that power is odd, y equals x to the fifth power. All of those are odd functions because they have odd exponents. And so if it's an odd function, the graph of this, y equals x, okay, starts low and ends high. And so if we looked at the limit of this as x approaches negative infinity, as x goes this direction forever, y is going that direction forever. And so the answer to this would be, as the limit approaches negative infinity, the y value is going to negative infinity as well. If we did it for positive infinity, the limit as x approaches positive infinity for this, it's still positive infinity. Okay, because as x gets bigger and bigger forever, the y is also getting bigger and bigger forever. If we looked at the cubic graph, okay, it's still doing the same thing. It's starting low and ending high. And so all the odd functions that have a power that's odd are going to do the exact same thing. It's going to start low and end high. If it's negative, any of those, it'd be backwards. So like y equals negative x would be decreasing. And so if we found the limit on this side, this one would be positive infinity. And as x gets bigger and bigger and bigger, y is going down forever. So this one would be negative infinity. And so then for our even functions, that would be y equals x to the second power, y equals x to the fourth power, and so on. And so looking at even functions, it's going to start high, and it's going to end high. And so no matter which direction you go, if you find the limit as x approaches negative infinity, or you have the limit as x approaches positive infinity, so as we go this way, for the x value, this is going up forever. So that limit would be positive infinity. As I go left forever, for the x values, the y values are all going up forever. So that one would also be infinity. And so if you have negative, so let's say y equals negative x squared, okay, this one would be the limit as x approaches negative infinity would also be, so as I go left forever, I'm also going to go down forever. So that would be negative infinity. Same thing here. As I go right forever, the limit as x approaches positive infinity will equal negative infinity because we're going down forever. So it's all thinking about like what's happening as you're going left or right. So positive infinity or negative infinity. So what's happening if you're going left and right? What's happening to the y values? Are the y values going up? Are they going down? Are they approaching a certain value? So that's what you're really focusing on, is what is the y value doing as x gets really, 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 really small or really, really, really big. Okay, so that's the difference between odd functions and even functions. And that'll come into play as we talk about this next little piece. So when we talked about rational functions, we had 3 different categories when we were talking about the horizontal or the slant asymptotes. And so small over large was y equals 0. Large over small was a slant. And same over same was the fraction. Okay, so whatever coefficient, like let's say this was 3x squared over 4x squared, it's got the same powers in the numerator as it does in the denominator, and so this would be 3/4. So that was the fraction. Well, when we were talking, like when we did y equals 1 over x, that was this graph that we looked at the very beginning. I'm really good at drawing. Okay, so that was the original graph that we looked at. Well, the horizontal asymptote here was y equals 0. And so if it's y equals 0, that graph is going to get closer and closer and closer and closer and closer to 0. Whereas if we were to graph this, an equation that looks like this, we would have, that's 1, and then this would be at y equals 3/4. And so if I graphed this one, it would get closer and closer and closer and closer to not 0 now, but it would get closer and closer and closer to the value 3/4. And so the limit here would be, as x approaches infinity, would be 3/4. And it'd be the same over here on either side, because this one's also getting closer and closer and closer to 3/4, except it's coming from the bottom instead of coming from the top, like this side. So you're thinking about what's happening to those asymptotes for each of those. The slant, you could have something that looks like this. You actually have an example of it on the graphs page, the very first assignment that you're doing. So let's say like we have a vertical asymptote, and then we have a slant asymptote. So here, your graph could look something like this. And so if your graph looks something like this, if you find the limit, of something that looks like this, as x approaches negative infinity, it's going to be negative infinity. Because as you go left, you're going down forever. Same thing here. The limit as x approaches positive infinity, as you go right forever, you're going up forever. And so this would be positive infinity. So a lot of times it's positive infinity or negative infinity. A lot of times it's 0. A lot of times it's that fraction. And so you just have to look at each one kind of separately. Is it small over large? Is it large over small? Or is it same over same? And so let's look at a few examples of this real quick. Okay, so this one, because the exponents are the same, it'd be same over same. And so we just actually did one just like this. And so what you can do is you're like, okay, I can ignore the rest of this, because only at infinity, only the strongest part of that graph or that equation is going to matter. And so if we get rid of everything, the x cubed and the x cubed really goes away, and so it's y equals 3/4 is all that's left, all that didn't divide out. And so we have 3/4, and so the limit would equal 3/4. Okay, and the basis behind that is what we talked about with our asymptotes back a while ago. Same thing here. We can get rid of this part because it's not the strongest part of this equation. The highest degree holds the most power. And so this is x squared and this is x. And so what is going to end up happening is I have 5/3 x. Well, if I have 5/3 x, that's an odd function. So if we go back, it's just a linear equation. And so it's going to start low and end high because it's positive. So this is what this graph would look like. As I go to negative infinity, this graph is going to also go to negative infinity. Okay, then we have another equation here. I can get rid of the back part. All I'm caring about is this. So this is going to go away. This ends up being x to the 4th, but it's negative. And so if we graph that, it'll look something like this. And so as we go to positive infinity, it's going to go to negative infinity here. Okay, so you can kind of use what's happening at the extremes for each one of these to see what's going on with each of these. So hopefully that makes a little bit more sense for your limits. And if all else fails, graph it and see what's happening in each of those. And hopefully that helps you out.